Introduction. Hello everyone. Today I am going to talk about three important types of data used in statistics and data analysis. These are descriptive data, inferential data, and categorical data. Data plays a very important role in many fields such as science, medicine, business, and technology. In order to understand information correctly, we need to classify and analyze data in different ways. In this presentation, I will explain what these three types of data mean, how they are used, and provide simple examples to make the concepts easier to understand. Descriptive data. First, let's talk about descriptive data. Descriptive data is used to describe, summarize, and organize information. It helps us understand the main characteristics of a dataset without making predictions about future data. In descriptive statistics, we usually calculate several important values. These include mean, which is the average value median, which is the middle value mode, which is the most frequent value minimum and maximum values range, which is the difference between the smallest and largest value. These measures help us quickly understand what the data looks like. For example, imagine a teacher wants to analyze the test scores of students in a class. Suppose the scores are 70, 75, 80, 85, and 90. Using descriptive data, the teacher can calculate the average score, identify the highest and lowest scores, and understand how students performed overall. Descriptive data does not make predictions. It only helps us describe what already exists in the data. Another common way to present descriptive data is through visualizations, such as bar charts, histograms, pie charts, line graphs. These visual tools help people easily understand patterns and distributions in data. In summary, descriptive data answers questions like, what is happening in the data? What is the average value? How is the data distributed? Inferential data. Now let's move on to inferential data, also known as inferential statistics. Inferential data is used to make conclusions or predictions about a large population based on a smaller sample of data. In many real-world situations, it is impossible to collect data from every single person or object in a population. Therefore, researchers collect data from a sample, which is a smaller group that represents the population. Using statistical methods, researchers can then make inferences, or logical conclusions, about the entire population. For example, imagine a university wants to know whether students are satisfied with online learning. Instead of asking every student, the university surveys 200 students randomly. If the results show that 75% of the surveyed students are satisfied, researchers may infer that about 75% of the entire student population is also satisfied. This is an example of inferential data analysis. Several important statistical techniques are used in inferential statistics, such as hypothesis testing, confidence intervals, regression analysis, probability analysis. These methods help researchers determine whether their conclusions are statistically reliable. Inferential data is widely used in many fields, including medical research, economics, social sciences, machine learning, and artificial intelligence. For example, medical researchers often test new medicines on a small group of patients. Based on the results, they infer whether the treatment will work for a larger population. So in simple terms, inferential data helps answer questions like, what will probably happen in the future? What conclusions can we draw from this sample? Does this pattern apply to the whole population? Categorical data. The third type of data we will discuss is categorical data. Categorical data represents groups, labels, or categories rather than numerical values. Instead of measuring quantities, categorical data describes types or classifications. For example, consider the following variables: gender, male, female color, red, blue, green, country, USA, Japan, Germany, type of transportation, car, bus, bicycle. All of these are examples of categorical data because they represent categories. Categorical data can be divided into two main types. Nominal data. Nominal data represents categories without any specific order. Examples include eye color, nationality, types of animals. There is no ranking between these categories. Ordinal data. Ordinal data represents categories that have a meaningful order or ranking. Examples include education level, high school, bachelor, master, PhD, satisfaction level, low, medium, high, product ratings, 1 star to 5 stars. In ordinal data, the categories follow a logical order. Categorical data is often analyzed using frequency counts and percentage distributions. It is commonly visualized using bar charts, pie charts. Categorical data is widely used in surveys, questionnaires, and social science research. Conclusion. To conclude, understanding different types of data is essential for analyzing information correctly. In this presentation, we discuss three important types of data. First, descriptive data, which helps summarize and describe the main features of a dataset. Second, inferential data, which allows researchers to make conclusions or predictions about a large population based on a sample. And third, categorical data, which organizes information into groups or categories rather than numerical measurements. Each of these types of data plays an important role in statistics, research, and data analysis. Understanding these concepts helps researchers and analysts make better decisions based on data. Thank you for your attention.